This lesson is section 9.01. It's kind of a preliminary lesson as we start working on trigonometry. So we're going to start off with just some rules from right triangles. In the warm-ups, we would have done the 4 basic Pythagorean triples. These are triples that you just have to memorize. You've got to know these. They're always on the ACTs. They come up later in pre-calculus. They come up in calculus. They're just important to know. So one of the most basic Pythagorean triples is 3, 4, 5. What this means is if the legs of any right triangle are 3 and 4, then the hypotenuse must be 5. The next one you need to know is 5, 12, 13. Again, if the legs are 5 and 12, the hypotenuse is 13. Notice, the hypotenuse is the longest side of a triangle. Therefore, of the Pythagorean values that we have here, the largest number must be the c. Of course, we know the Pythagorean theorem is a squared plus b squared equals c squared. If you plug in 5, 25 plus 144 is 169, and 13 squared is also going to be 169, so that's showing that that works. The next one we have is 7, 24, 25. This one you could check it out if you wanted to. I'll just prove it to you real quick. 7 squared plus 24 squared gives me this, and then if I do 25 squared, that is exactly the same thing. So those are going to be the next Pythagorean triple. The last one we have is 8, 15, 17. If you don't believe me, you're welcome to test it out. But that is our 4th Pythagorean triple. Now, the nice thing about this is if 3, 4, 5 works, because of similar triangles, we also know that 6, 8, 10 will work. See what I did there? Just multiplied them all by 2. I can multiply all of these by 3. I can multiply them all by 4. And I can get new values that would also work. So if I had 12 and 16, that's going to be 20. Okay, so I can always multiply by any number that I want to multiply as long as I do it to the entire triangle, the entire group of triples. Okay, so on here, multiply them all by 2. You might see something like that somewhere. I can also divide them all by 2. Okay, so I could have 2.5, 6, and 6.5. That would be another Pythagorean triple. Watch, 2.5 squared plus 6 squared gives me this. If I take the square root of that, I get this answer, 6.5, another Pythagorean triple. I could divide them all by 3. I could get 5/3, divide that by 3, and divide that by 3. There's another Pythagorean triple. Okay? So if you recognize these, it can save you a lot of time. Now, you may not recognize that, but watch. If I multiplied it by 3, 5, 12, 13. See, there it is. All right, so, okay, let's take this one. Let's divide this one by 5. I could have 7/5, 24/5, and 5, another Pythagorean triple. You get the idea with this. We can always multiply or divide by the same number, and because of similar triangles, we would end up having another Pythagorean triple. All right, 45, 45, 90s. If we have a 45, 45, 90 triangle, you should remember from geometry that these legs have to be congruent. This is a leg, this is a leg. See how they form that L? These must be the same. If I want to figure out what this is, I can use the Pythagorean theorem. A squared plus b squared equals c squared. Add these two together, I get 2x squared is c squared. Take the square root, I get c equals the square root of x squared is x, radical 2. That is the ratio of these sides. So the ratio goes, in fact, I'm going to jot this down. This is side A, B. So across from angle A is side A, across from angle B is side B, across from angle C is side C. So the ratio of A to B to C is x to x to x radical 2. I can say that. I can divide everything by x. I can say it's 1 to radical 2, right? Same thing if I divide everything through by x. What about for a 30, 60, 90? Okay, well, I'm going to show you this by showing you an equilateral triangle. And an equilateral triangle, all of these angles would have been 60 to start with. Okay, now if it's all 60, then all these sides have to be the same. So this is going to be x, this is going to be x, this is going to be x. But I'm not trying to work with the 60 degrees. I want a 30, 60, and I want a 90. So I'm going to drop this down here. And this is the triangle that I'm now going to work with. I'm going to ignore the other half. Well, if this was x, what's it going to be now? This is going to be half of an x, right? So if I want to find this missing side, I can say then that I'm going to do 1/2 x squared plus, I'll just call this side b, plus b squared equals c squared. If I square 1/2, I get 1/4. And that's going to stay the same. I'm going to subtract 1/4. Well, if I have 1x squared and I subtract a fourth, that's going to give me 3/4 x squared. And now I'm going to take the square root of both sides. Square root of 3 I can't do. Square root of 4 is 2. And the square root of x squared is going to be x. Okay? So, here's what I have for this triangle then. I've got 30. So across from this 30 side is 1/2 x. Across from the 60 side is this right here. Across from the 60 side is radical 3 over 2x. And across from this 90 side is going to be x. Now, that's a ratio that I can use. Okay? I would call this A, this B, and this C. But sometimes people don't like to use fractions, so instead of thinking of it like this, what could I do to the triangle to eliminate fractions? I could multiply every side by 2, right? So let's multiply this side by 2. Let's multiply this side by 2, and we just get x radical 3. It's kind of hard to see. I'll write it again. Multiply this side by 2. Now we don't have to deal with fractions. So now our ratio to A is x. The B side is x radical 3, and the C side is 2x. And that's our ratio. It goes x to x radical 3 to 2x. Or, if I want to divide through by x, 1 to radical 3 to 2. Whichever way you want to think of it. All right, let's see how we're going to use these problems now. So if I'm trying to solve this, I'm going to draw a little picture. I know this has to be C. A and B don't really matter. So I've got side B is going to be 12, side C is going to be 20. I'm trying to find side A. Well, I don't recognize this triple right off, maybe. So I can say, what can 12 and 20 both be divided by? Well, they can both be divided by 4. So I'm going to put a little 4 here. 12 divided by 4 is going to give me 3. 20 divided by 4 is going to give me 5. So that's what I get when I divide these by 4, right? So now I know I can see the triple, 3 blank 5. Look back up here. What was that triple? These are the main triples right here. 3 blank 5. 4, right? So this side would have been 4 if it was just 3, 4, 5. But what did we multiply them all by? By 4, right? So therefore A is going to have to be 16. All right, let's look at the next one. Again, you have to know these basic triples. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Just kind of squeezing them all in there. But those are triples that will make your life a lot easier if you know them, as far as math goes. Okay, so here's our right angle. So this is going to be my side C. A and B don't really matter. Side A is 3.5. Side B is 12. So anytime I have decimals like this, I may not recognize it at first. But I can think, what can I do to get rid of the decimals? Well, multiply by 2. If I multiply this by 2, I'm going to get 7. Multiply this by 2, I'm going to get 24. So what side is missing? 25, right? But these are the actual values. So I have to think this was 7 divided by 2, 24 divided by 2. So my answer is going to be 25 divided by 2, which is 12.5. All right. Let's go ahead now and look at the next one. Another triangle here. You draw it as much as you need to. We got 45, so that's 45. This has to be, C is always going to be the right angle. That's going to be 12. And we're supposed to find the other missing sides. In a 45, 45, 90 triangle, look back up here. It has to go x, x, x radical 2. So this is the x radical 2 side. So they're telling us that this x radical 2 side has to equal 12. Well, to solve for x, I'm going to have to divide by radical 2. You might remember that we want to rationalize this now. I can't just do 12 divided by radical 2. I want to find the exact answer. I multiply by radical 2. I get 12 radical 2. Radical 2 times radical 2 is radical 4, which is just 2. 12 radical 2 divided by 2, multiply the parts that are alike. That's going to be 6 radical 2 then. Both of these are x values. So if x is 6 radical 2, that's going to be the answer for A, and that's going to be the answer for B. Okay? All right, let's draw a picture for this one. C is always the right angle. We'll put A here. That's 30 degrees. Put B here. Side B is the side across from angle B. So they're telling us that this side is 6. This is also 60 degrees. Well, across from the 30 side is our x. Across from our 60 side is our x radical 3 side. And across from here is our 2x side. Well, in order to solve this triangle, I have to solve for x. Okay, and where this all came from was right here. X, x radical 3, 2x. I went through a lot of work to prove to you that that's the ratio, but here's what you just want to remember. It always goes x, x radical 3, 2x. 1 is the smallest number. Radical 3 is 1.7, so it has to be across from the median angle, medium-sized angle. And then 2 is the largest number, so it has to be across from the largest angle. All right, so back here again, x radical 3 has to equal 6. So I'm going to have to solve that by dividing by radical 3. So I have to rationalize this. Radical 3, radical 3. So x is going to be 6 radical 3 over radical 3 times radical 3 is radical 9, which is just 3. So x then is going to be 2 radical 3. So this is my x side. So this is 2 radical 3. Well, this side has to be 2 times x. So I'm going to have to do 2 times 2 radical 3. This side has to be 4 radical 3. So therefore, side A is 2 radical 3. Side C is 4 radical 3. All right. Down here, we're supposed to find side A, and angle B. Let's draw a picture. So we got C always has to be the right angle. Put A here, B here. Side B is across from angle B. This is 6. Side C is across from angle C. This is 6 radical 2. All right, guys, look at the pattern. 6 blank 6 radical 2. Well, look which one follows that pattern. 6 blank 6 radical 2. Well, what's the blank have to be? Just x. This was x, right? So this is going to have to be 6. What kind of triangle gives us this pattern of 6, 6, 6 radical 2? Well, look at it. 45, 45, 90, right? So therefore, this is 45, and this is 45. So finishing this up, side A had to be 6, angle A had to be 45 degrees, and angle B had to be 45 degrees. All right, let's look at the last one here. So we're going to draw a picture. Angle C is there, side angle A and B. Side A would be here, side C would be here. All right, do you notice how this missing side is going to be right here, and we've got 1/3 and we've got 2/3. If you really had no idea what to do, what could you use? Pythagorean theorem, right? But let's look at the pattern. This is twice as much as this. So which one of those triangles do we have it so that the hypotenuse is twice as much as one of the other sides? Well, that happens in a 30, 60, 90. So therefore, this would have to be the 30-degree angle because that's the short leg. So this has to be the x side. This has to be the 2x side. So the missing side has to be the x radical 3 side. Well, look at what x was. It was 1/3. So just plug in 1/3. So 1/3 times radical 3 is just radical 3 over 3. That's our missing side right there. So what does the missing angle have to be? Well, all the angles in a triangle add up to be 180, so that's got to be 60. So then side B has to be radical 3 over 3. Angle A was 30, and angle B was 60. Notice anytime we have a lowercase letter, that's a side. Uppercase or capitals, those are going to be angles. All right, guys, so what you're going to do then is you're going to work on these problems in here. Okay? You can go as fast as as you're able to. A lot of these are going to just be triples in here, but you got to figure out once you get to these are going to be our rules. Remember the rules for this. For 30s, 60, 90s, do you remember the pattern? Pause the video, see if you can remember it without looking. Did you get it? All right, write it down for 45, 45, 90s. That ratio. Pause the video. Okay. Now, see if you can write down all the triples. There are 4 sets of triples that I expect you to know. See if you can write them down. Pause it. All right. Hopefully you were able to get all that because these are the main things that you have to know, and you have to know them very well. Those are things that will help you a lot in trigonometry and in all your future math classes. All right, so finish those problems up.